Recording. Okay. Hello, everyone. This is lecture 5 of advanced drilling. And today we'll carry on with module 1. We are slowly but surely getting more and more into the technical side of things. Last time we finished talking about contracts and we were briefly, well, we talk about leasing, then we talk about basically international agreements that has to basically cross borders. And then we talk about drilling contracts per se, like which can be between an operator and a drilling contractor, etc., or even a landowner and a drilling contractor. And then we talk about IOCs, NOCs. I expect you to know the difference between the two. And then we started talking about like the basics functions of drilling rig, some things that they all have in common, even if they don't look alike. And then we talked about the personnel, the main personnel. That is much more than what this slide has, of course. And then we talked about the first activities that take place when you are beginning to your drilling operation. And we said you rig up and then you spud in. Spudding in is an old British word. Actually, no, it's not a British word. It's an American word, I think. But it has to do with potato. And it was really the act of, back in the day with the cable tool rig, you lift the bit and you drop it down for the first time. And that was basically spudding in. That's why you spudded your well on, I don't know, January 28th, 2025. And then you T'd it, you reach the total depth on February 15th. Right? TD is like checker flag, total depth. Rigging up is when you install your equipment that you need. And there is we said that some people that work for operators and basic or drilling contractors, rigging up is like a big thing, like rigging up the whole rig. For some people that they work for service companies, and there is more than 100 service companies involved in an onshore operation even, rigging up might mean like installing their own equipment. And they tell their boss, hey, I rigged up, everything okay, you know? So that's about the rigging up. You have the substructure, which is under the ground, basically, in the cellar, and is holding up, basically, the whole rig. Ultimately, is centered over the conductor pipe in the cellar. The substructure will support the derrick, mast, pipe, drawworks, and sometimes even the engines. So it's basically, it's supposed to hold a big mass, okay? It's like, it's a no joke equipment. It's the foundation on which your rig is temporarily built on. You are gonna hoist the mast, which is the mast is a collapsible version of the derrick, or assemble the derrick piece by piece. Mast is basically a derrick that is not a permanent structure. So it's, let's just say, not I don't want to use the word portable, but it's easier transportable in a sense of you don't need to transport the whole thing. You can like either bend it down and then transport it with a semi, or you can even break it into several pieces and transport it in containers. There you go. This is actually a derrick that is being well, it says derrick. It's really a mast because it's collapsible. It's not a completely permanent structure. And yeah, you have to, it's a big component of the rig, which takes a lot of space. So it requires attention. And then you have other drilling equipment moved to location, like the mud pumps, the draw works, and we're going to talk about those. Those are heavy equipment, okay? They are the heavy stuff that you need to take special care of. You erect stairways, guardrails, handrails, these are small stuff. Auxiliary equipment is installed for supplying electricity, water, compressed gas, storage facilities, and living quarters for the crew. They are called the man camp. I used to call it the trailer camp, but it's basically a container that is like an apartment inside, several containers. And then you bring equipment that you are gonna need for the drilling, like drill pipe, drill collars, mud supplies, for the drilling contractor to start making hole. And then you spud in, which is basically the beginning of the drilling operations for a well. And yeah, it originated from the cable tool era when spudding was the act of hoisting the drill stem and letting it fall freely. The force that the drill bit hit the bottom, hit the rock, was sufficient to break it, and that was basically the first act of drilling with a cable tool rig. Now we use rotary rigs, so it's basically you start rotating, applying weight on the bit. That's when you're spudding, basically. The crew takes a large 18 to 36-inch bit and lowers it into the conductor pipe, continuing to add drill pipe until it reaches the bottom, starts rotating clockwise, and we call this making hole. Basically, you have a positive ROP, rate of penetration into the earth. Making hole is basically a term that we use for we are making hole. We are really operating and extending our well. Sorry, some important equipment here that we will talk about. We have the crown block, the traveling block. The crown block is the top of the derrick. It is staying stationary. The traveling block moves up and down, up and down. Okay, it's allowed to move down on the way up. The derricks are either 90 feet or 100 feet or 35, 40 feet. The 100 feet are able to pull out of the hole or even creep in the hole stands, which is like trebles, 3 joints together, 30 each, 90. And then you are allowed to be able to pull 3 of them together or pull down 3 of them together. The old 40 feet tall derrick can only do one stand, one joint of 30 feet. There are joints that are 31, a little bit longer, a little bit shorter, etc., etc. Now, on one side of the derrick, you have a wire rope which is attached to a winch, which is like a drum. Then you have basically connected to a gearbox and stuff. All this device here is into a blue, usually blue colored box. It's called the drawworks. And as you can imagine, it's very heavy, okay? And it requires a lot of power. And these are the drawworks. And the other side, you have the wire rope staying stationary with a hook. Basically, you have the hook that grabs it together and keeps it stationary. This side of the wire rope is allowed to move. That's the left on your screen. The right side is not allowed to move. So we call the left side, let me write for the people online. Okay, we said blue for the drawwork. So everything here is basically in a blue draw works. And then that side of the rope is called the fast line. Okay, it's allowed to move. This side is called the, can I write it here? Dead line. It's not allowed to move. Okay, and it's connected here. Now the thing is that here is basically when you are holding it, you are damaging the wire rope after some time. So you have a process called slip and cut that basically after some time, you have to move the wire rope a little bit, detach, move, and then attach it to a different point. So you don't create a weak point there. Eventually it will break. So they do it routinely every few days.
So how do they
Yes,
determine the point at which they will cut the rope from?
Where?
How do they determine the point at which they will cut and they will do the slip and cut?
Oh, they write it on the screen after they do it. So you keep a record. We did slip and cut. So every specific amount of time they do it for safety purposes. And the screen is shared with everybody. I think I'm going to have a picture of, it's called the INDR screen. And everybody on the rig, doesn't matter if you are a service company or the operator or the company man, they have access to that screen. So if you make a measurement, the mat logger makes a measurement, says this is the kind of rock I'm seeing, cuttings I'm seeing, it's gonna be on the screen. If the crew members, they measure the mat weight coming in and the mat weight going in and the mat weight coming out, they put it on the screen every few feet or something. So everybody has access to this data on the rig. And yeah, it happens it depends on the operators or the rig policy, I guess, rig owner's policy. But yeah, so sections of drill pipe above the bit are screwed together in a drill string, connecting the bottom hole equipment to the surface equipment. These are basically the drill pipe, joints of drill pipe. You have one joint is something between 30 to 33 feet. One stand is 3 joints. So it's something like 91 to 95 feet, can I say? Something like that. Can be 89, somewhere there. That's why the height of the derrick is 100 feet or 40 feet. The drilling crew keeps adding lengths of drill pipe while making hole. Now remember I told you the rig may have a capacity to pull in, pull out, or run in stands, which is 3 together. But when we are drilling, when we are actually making hole, you are going in one joint at a time, okay? And the joint that is about to get in is in the mouse hole. It goes from the rack to the mouse hole, and then from the mouse hole down the hole, down the actual well. Periodically, drilling is stopped and steel pipes called casing are lowered in the hole and cemented in place. Drilling carries on with a smaller sized hole below the casing shoe. So every time you run casing, you cement it, and then you go back in with a smaller bit and you drill through that and carry on the well, right? So it's to your benefit to do as low number of drill, basically, you don't want to do many drill strings in a sense of, you don't want to go from, you go from big to smaller, 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 And then when you reach where you want to produce from, you have a very small hole, and you cannot run anything inside, like a pump or something. So you need to make sure that you don't go, how do you say? You don't misplan your well, and you end up with not being able to, because you need to know what you are expecting to produce, flow rate wise, etc. There is a well, or there was a well in Gulf of Mexico. I think it was called the Blackbeard. It had 14 strings of casing inside. So it started by very big, and then it was like a tiny at the production zone. And when we do the last module, I hope that we have the time to do it, managed pressure drilling, we are going to talk about a technology called dual gradient drilling that helps you offshore to use less casing strings than what you would have done otherwise. It's a very cutting edge technology that is used for that. The power system. So we're going to look at the power.
Let me quickly ask a question.
Yeah,
what influence or what informs the decision of, do I need to drill, for example, now, instead of using many casing strings, why not just use one, then change it to the production? Is there a decision whereby you use one, you change it to this?
Have you seen matte windows before? We are going to see in this chapter, in this module, but do you know about matte windows?
Matte windows.
Matte windows.
Mod window.
MUD windows.
No.
Okay, we're going to see those. We're going to see about casing design. Basically, it's not completely on your control. You can use matte that has certain weight. It cannot be lower than this, it cannot be bigger than this. And that dictates how many casing strings we are going to use, and also how deep we are going to run them, each one. And we're going to see that maybe in 2 weeks' time, maximum 3 weeks' time, something like that. It's going to be in this module. It's a good question. Yeah, we're going to see casing design. But there are other stuff, like these modern day technologies that I mentioned, they play with the windows a little bit. Like the window was in what is the variation of your mud weight that can be? You want the biggest variation that you can get, okay? If you have a very narrow mud window, it means that your mud cannot be bigger than this, cannot be smaller than this, your mud weight. So you have very small flexibility. Okay, you make a little bit of a mistake or something goes wrong and then you are in trouble. You want to make it as big as possible. And there are technologies, smart technologies that passively try to achieve that. In fact, my old advanced drilling professors joined industry project. It was like the name of his research group, basically. It was called Wider Windows, because they were trying to look into technologies that widens the windows. You want wider windows, wider mud windows. And the undergrads from this class know they have seen this before, mud windows, so they should understand what I'm saying now. They have done casing design last year, module 3, I think. But we're going to see that in this module soon. Okay, the power system. The power generation system is needed to run the machinery and equipment driving the rig's various components, auxiliary power requirement for lights, etc. I mean, these are it's small, it sounds insignificant, but it's important. You know, you need lights, you need clean water, you need a bunch of stuff that are supplementary or auxiliary. They are still needed, but it's not for drilling the hole necessarily or directly. But the main things, the two equipment that require the most power in the rig are the mud pumps and what I described earlier, the blue thing, the drawworks. These are the ones that are the most power consuming pieces of equipment on the rig. Offshore rigs, you are basically in a ship, and you need thrusters that are propellers facing each other, facing against each other, that are used to keep the rig in place. And they are also very power intensive. Tremendous total power requirements exceeding 50,000 horsepower. Where is the rig's power coming from? We have compression, ignition, diesel engines. That's the most common source. Yeah, if you're familiar, if you drive a gasoline car, the pistons, they compress the fuel. Well, it mixes gasoline with air, and the mixture, as it's called, is entering the pistons. The piston compress the mixture, and then you have the spark plug, which basically induces current in the mixture, and it basically makes it burn or explode and moves the piston down, creating motion. Diesel is a little bit easier in the sense that you compress it and it ignites on its own, basically. You don't need spark plugs, which is good for the people working. They don't need to replace any of the diesel pumps. These days, you have natural gas and liquefied petroleum gas engines that they require spark ignition. These are harder to transport than diesel engines, and they are more complicated. Also, when you see gas involved, it means having gas under pressure, okay? So when you have something like gas under pressure, it's very dangerous. It's something dangerous. You are in danger of explosion, you are in danger of other stuff, and they are in general less, it's like, this is where the industry is heading towards. It's gonna take a while. They are cleaner, but they are more complicated and currently less safe. And also, you can be powered directly from electricity. And those of you who went to the field trip last 2 Septembers ago, we have been to a rig that was operating on a high line. So it didn't have diesel engines. It was connected to the grid and working through that. Okay, this is practical, but you need to be in a location where electricity is available, etc., etc. So it's not for everywhere, of course. Any questions? Yeah, feel free to cut me off.
Sorry, on a particular rig, is there a situation whereby you have a combination of this power supply?
No, not to my knowledge, because components that are downstream of that will have to be different. Like the transmission, is like, we're going to talk about it a little bit later, but it's like, the diesel engine makes chemical energy to mechanical energy, which is motion, or electricity. How do you transmit that down to the rest of the equipment? You will need some differences there. You will need some, generally every rig is designed for a specific type of, you can have various sources for, you can have things working on an AC current, things working on a DC current, but generally speaking, it's impractical to have rigs that work on 2 different sources. But I can imagine people designing rigs that can do that at some point, if it makes sense. I haven't been in one that had, in fact, all the rigs I have been through, they had diesel engines, to be honest, that I actually worked on. They had diesel engines. And that was in the Permian, either on the West Texas side or the New Mexico side. It was diesel. The one we have seen here in Williston that was on Highline, I think Neighbors has, how many of those? They told us, I forgot. I don't know how many of those they have. I think they have 4 working on the highline, something like that. It's a sort of a new thing, you know. If you make it, basically it depends on where you are. If you are in the middle of the desert, I don't think you want a rig working on a highline, right?
No.
You want diesel engines. If you are offshore, again, it won't be, unless you are very shallow, or if you are in the marsh in Louisiana, which is basically next to the land, maybe you have access. But yeah, it depends on a lot of stuff. Depends on a lot of stuff. Power transmission is what I was describing before. What does the engine do? It takes chemical energy, diesel, and it converts it to other form of energy. Ultimately, you want it to become motion. You want it to rotate the drawworks. You want it to make the pump mat, etc., etc. So you want chemical energy, which is stored in a liquid, to become motion. How does this transmission take place? So there is 2 ways, 2 main ways. One is, well, let's see here. Power is transferred from the engines to the different rig systems by belts, chains, and drive shafts on a mechanical rig. So mechanical is one method. It's like you make the diesel, create motion, rotate something basically, and from there, you transmit the rotation. You have belts, pulleys, you know, one thing rotates, makes the other thing rotate, and then the other thing rotate, and you transmit the motion. And of course, you have losses all along by friction, etc. Things are getting hot, etc., etc. That's the old style, the more traditional, old sort of way of they are doing it. There are some disadvantages to it. The more modern way is with a DC electrical power. So you do it electrically. Okay, you create, you have diesel, energy stored in liquid form. You burn it, you make electricity. Electricity transmits, you get the electricity to the drawworks, you get electricity to the mud pump, etc., etc. So you can either have mechanical drive or electric drive. These are the 2 types. There are some disadvantages with a mechanical drive, is that everything needs to be aligned a certain way, because you have pulleys, belts, they need to be aligned a certain way. Okay, you lose the alignment and you are in trouble. You might not only lose the motion, you might actually cause very big damage, expensive damage. And this is problems they had back in the day. With the electric drive, you are more flexible, but it's a more high-tech equipment that you are dealing with. It's a more, because the electricity demands are quite heavy. What did I do here? Oh. In mechanical drive rigs, a compound is placed right after the engines, which is the collection of pulleys, belt, etc., connecting to the rig components that require power, such as the mud pumps and drawworks. So you have the engines, the compound, and then everything else on the rig that takes this power, like the drawworks, the mud pumps, etc., etc. The compound is basically where the things that are moving are, and this is what needs to be aligned properly. With the compounded engines, that's the mechanical drive rigs, the driller can use 1, 2, or 3, basically, you have the diesel engines and you can make any combination you like. Compounds are heavy and complicated, and they need to be lined up with both the engines and the drawworks. And this is a little bit of it's the complication that if you lose the lining up, you are in trouble, basically. In electric drive rigs, the diesel engines, they produce AC, alternating current. Okay, they burn diesel, they produce AC. Everything on the rig works with DC current, direct current. How do you go from an AC current to a DC current? Do you know? Transformer, exactly. Okay. In the rig, we have a whole container with transformers. It's called the silicon controlled rectifier. And it's a very, very well air conditioned room because they need to keep the temperature at a certain point. And in the summer, everybody goes and eats lunch in the SCR container because it's, it's cool. Everywhere else is hot. Everybody, if they get tired and it's too hot, they go into the SCR room. It's a very important room or a container because if something there breaks, you don't have electricity to the components of the rig. But it's basically, think of it as a gigantic transformer, okay? And it takes the power from the diesel to the drawer, to the equipment on the rig. In the Dracola lab, we have a SCR room that you can visit and check it out. Basically, it's not working, but you can see how it is. This is a picture of the mechanical drive that I was mentioning earlier. A schematic of the mechanical drive. You have 3 diesel engines. 1, 2, 3, and then you have the compound, and then you have the various equipment on the rig that require power, like drawers, mud pump, another mud pump, rotary table. So it needs to go mechanically from the engine, becomes motion, and then the motion is transmitted to the other stuff. That's for the mechanical drive. For the electric drive, you have this, which is basically the SCR room inside. Electric motors have a much higher initial torque than engines, which is good for torque-intensive operations. Basically, here I'm saying modern day rigs, they are more almost exclusively electric drive. You won't find many mechanical drive anymore. You will, but it's not very common. And this is how it looks on the outside. SCR room, very important. Think of it as a gigantic transformer. I think this might be from Louisiana because I think this coffee cup is community coffee. I think they have a lot of those in Louisiana. CC, community coffee is called. No, I see.
I've not been there.
Yeah, I didn't notice that before. So that about the power system. Diesel engines, mechanical drive or electric drive, this kind of stuff. You create your power. Now you need to use it. The hoisting system uses the most power of all the other 4 systems of the rig. It's composed by stuff that we talked about earlier. Crown block, traveling block, the drawers, this is the blue thing, fast line that moves, dead line that stays stationary. And look at that, we have the dead line anchor, that's where it's grabbed. And then the storage reel here, when you do slip and cut, this is where you do it. Okay, let me draw for the people in the online to see. This is where you do slip and cut. Okay, this is where you do slip and cut. And there is a hook here. And basically, this hook is the one that moves up and down, and you can basically attach any weight you want on it. We're going to see what is attached on it, but basically, it's capable of lifting and dropping weight. All right. Oh, this system, this part of the rig that we talked about in the first class, we spent time doing something that they do in statics, free body diagram and analysis of the force balance on. It's called block and toggle. So if somebody tells you the block and toggle system of the rig, block, I'm writing with the mouse, and toggle. This is what they mean, this part of the rig. And it's about the hoisting system. Block and toggle, basically. A drill pipe or casing will be lifted and lowered to complete the well. It's primarily composed of the derrick, traveling block system, and the deadline anchor. A second, the traveling block moves vertically up and down, transmitting motion to the drill string. Floormen or roughnecks can help to safely place these pipes on the pipe rack. We're going to see later what the pipe rack is. It's on the side of the derrick and it has the pipes racked on. The deadline anchor mainly helps the replacement of the drilling line when subjected to wearing via the slip and cut procedure. Well, it's a routine procedure that is done to prevent wearing, excessive wearing that will break the wire rope. This is the pipe rack. And this with the black is the pipe rack. It's important, there are some rigs that you can move it around. And you can move it because the way the wind blows, okay? It can act like a sail and eventually bend your derrick down. Because you know the wind can be very strong, right? So you might want to move it. There are some rigs that the pipe rack is movable and they move it a certain way so that it prevents the wind from breaking. You want to put the narrow side towards the wind so it doesn't basically bend over the entire rig. This container here, this blue container, is called the dog house. And that's basically the office. Okay. I know some people, they were trying to get a job on the rig. So they went in and they said, how about we get a job painting dog houses? So they were going from rig to rig in the summer. I think they were A&M students and they were painting dog houses. So this, yeah.
Why did they call it dog house?
I don't know. Somebody used it as a nickname and it stuck, I guess. There is a lot of stuff on the rig that are named after animals. And there was an open question like list 5 components of a drilling rig that are named after an animal, like dog house, monkey board, cat head, dog leg severity, wildcat, well, I guess. What else?
Spider something?
Yeah. What did you say, Nassim?
Spider something.
Spider?
Yeah, there is something in the rig named Spider. It has 6 legs like a spider.
I don't know. Maybe. So, but there is a lot. There is a lot of stuff. There is the rat hole, the mouse hole, all this stuff. Now, this is not a very good picture, okay? But here is basically the runway. It's called the catwalk, actually. That's where you will lift the pipe up to the rig. Okay, and this here that you see, do you see this thing here? This two-door system, you know what it's called? It's called the V door. Okay, V door. And there is an old joke on the rig that they make to new people, but it's now so famous that everybody knows about it. Is that when you get a new worker on the rig, you tell him, hey, go to the company man and tell him to give you the keys to the window. You know? And it's an old joke, like when the company man, you are going to go to the company man or to the tool pusher and he's going to be busy with a million stuff, and you're going to tell him, somebody asking for the keys to the window, and everybody knows there is no keys to the window, but they all know about this joke. So it's like
Trying to show it's new here.
yeah, and it's like an ongoing joke that everybody knows about it, so they don't. It doesn't work anymore, you know. Prank, like the keys to the window. Where is the keys to the window located? There is no keys to the window. They have a latch. They have a latch. The windows have a latch. But there's no key. It's an old joke. Like they were telling it to us since I was at school. Where is the keys to the window? And basically, it's. Wait a minute. There is 4 people online, 3 people online, and I only see 1 showing up on the picture. Okay, now I see all of them. Okay, yeah, there is no key to the window. Remember that. One day when I was on the rig, they made a prank on a guy that basically they told him we were eating wings. Okay, we got wings from a Wingstop place in Midland, and somebody came by and he said, "Oh, I didn't know they delivered to the rig." But it wasn't delivered to the rig. Like we went and got it from Midland, and he said, and somebody took it and saw it an opportunity to make a joke to him. And he said, you know, there is a company specifically delivers food to the rig. And the guy comes in with the FRCs to bring you your food. FRCs is the fire retardant suit to bring you your food. But there is 2 conditions. Like 1, you need to tip him well. And 2, you need to go and ask permission from the company man. So he went to the company man to ask permission to get the food to the rig, and the company man got mad, and he called the guy's the guy who was making the prank. He called the guy's company, and he got him in trouble.
Wow.
Yeah. But yeah, these are the kind of pranks. But the video is a very, very old joke. Like, give me the keys to the window, and only the new person will know that will think that there is a key to the window. And then you go to the tool pusher or something, and he's busy with a million stuff, and you tell him, "Oh, give me." Anyway, this is how the pipe rack works. Now, you know, the roughnecks, they hold the pipe rack from the bottom, right? And they direct it. Somebody needs to do the work on the top. It's not enough. Like you need to move it. Somebody needs to hold the pipe rack on the top, and that would be the derrick man, standing on the monkey board, on the not at the. You see here. And if you see well, you don't see. I don't think it's visible. Here, there is a line. And this is his safety line. Basically, it's like there is a stopper, and if something happens on the rig, it will basically grab it and go down. The Geronimo line. Okay? Geronimo line. Let me write it very quickly. Geronimo line. And if something happens, he will grab it and go down. And I heard the story, actually, from my advanced drilling professor, that a rig offshore got fire, and the derrick man grabbed the line, and basically he didn't stop. He basically almost burned his hands. And they asked him why he didn't grab the brake. He said, I didn't want to stop. It was burning, you know. But anyway, yeah, that must have been an old story. But anyway, this is basically the Geronimo line, which is used for the safety of the derrick man. The derrick man also wears a harness by going up the rig. He wears a harness, so if he falls, because the monkey board that he's standing on is basically, you know, how do you say the floor that is like a lot of pipes, basically a lot of cylinders, one after the other, and you are working on it. It's not very stable. It's not very stable. So he needs safety. Also, there is wind as well. And you know that they mark the joints, the stands. The reason why they mark them is that sometimes one cannot connect with another one very easily. So they mark the one, number 12 connects with number 13. So they basically mark them the way, the sequence they got out, you want them to go back in the same way. Okay. And sometimes they keep that between wells. As in, we use this drill pipe in this well, in this sequence, we're gonna use it in this well in the same sequence as well. Oops, let me clean. Now, slips is a very important equipment that you see on the rig floor, and we did see a pair of slips when we went to the field trip. And it's basically used when the drill string, as is the connection of all the drill pipes, or with other stuff all the way to the bit, is held by the hook. You know, it's a very high weight, right? It's a tremendous amount of weight. Okay, when you do not have it connected to the hook, how do you keep it from like falling into the bottom of the hole? If it falls to the bottom of the hole, it's gonna damage the bit. Okay, it's very, very heavy. Okay, so how do you keep it there from not falling in? You have this piece of equipment that is called the slips, and you put it there to hold it together. Okay, and oh, let me make. I know that you cannot see. Okay, now you can see, but how do I make it smaller? So, okay, these are the slips, and then installed in at the bottom, and this is how they look like. These teeth here, they are called dies, and they need to be replaced every now and then. Generally, yes. Question?
You said they need to be replaced every while?
Every some time. You have generally 2 slips on the floor, and then 1 spare at the not in the rig, on the side by the rig crew cabins. So you have one that is working and good to use it. There are some slips that need 2 people to hold them, you know. There are some slips that are small, they're still heavy, don't get me wrong. And you need to be very careful when you put them. You don't want your fingers to get stuck there. Be very, very careful. They are disgusting. You don't want to pick them up. It's gonna drain mud on you and stuff. But I mean, they are very necessary. Now, trick question is like, you know, you have that hook load is applying a weight or holding a weight, what would be the hook load when the slips are on?
Depends how much your blocks and top drive weigh.
No?
The load will be on the slip.
Say that?
The load will be on the slip.
The weight would be on the slip.
I mean, yeah, the weight will be on the
Okay, so what would be the hook load indication that you see on the screen?
zero.
Zero. That's how you know that the slips are on. If you see on the EDR screen, what we call weight on the bit equal to zero, it means that the hook, there is nothing held by the hook load. Somebody else is doing the lifting. So it's basically the slips are engaged, basically. They have teeth-like gripping elements called dies that fit into the drill pipe and prevent it from falling. And basically what they do is that they deform around the drill pipe. And this is how they create the latching, the engagement there. So they need to, because they deform, they need to be replaced every now and then. It's a very important equipment. Any questions on the hoisting equipment? Okay. This is how you lift and drop stuff, basically. Now, the third system that we're gonna look at, and we go through it very fast. I went through it very much slower in the undergrad class, module 1. Here I only cover the basics. It's the circulating system. This has to do with basically mud circulating throughout the web, okay? Down the hole, up. You have the mud pits where it's clean mud. It goes through the mud pits into the mud pump, gets pressurized, goes down hole, up the annulus, and then it's cleaned up by passing through various equipment, and then becomes clean again and gets back into the mud pits. Oh, we have another student online. Hello, Tito. Okay, so let's see the system. The system, basically the circulating system, main component is the mud pumps, the mud pits, mud mixing equipment, mud contaminant removal equipment, basically the cleaning equipment of the mud. And it looks like this. I'm not a big fan of this schematic from my old university. It has some things that are wrong. I think it was done by academics, purely academics, but it does the job I want to do for now. Basically, you have the mud tanks. Let me move this. You have the mud tanks. This is where there is the mud, clean mud, okay, ready to go downhole, okay? It gets picked up by the suction line of the mud pump. And it's important to be clean because you don't want dirty mud to get into the mud pump. It's going to damage it. It has particles, it's going to abrade it, it scratches it. You don't want that, okay? Then the mud pump applies pressure. It pressurizes the mud. So this discharge line is a high pressure line, okay? The mud leaves the mud pump at a very high pressure. And then it goes through the standpipe. The standpipe is taped onto one of the legs of the derrick, okay? It's basically, you know, the derrick has 4 legs. The standpipe is taped onto one of those legs. And it's a high pressure line again. And you have a gauge there, and you measure what we call SPP, standpipe pressure. Okay, that's the last measurement, last good measurement you have of pressure before entering the well. Then you go through the rotary hose, which is like a loose pipe, and then it's attached onto the swivel The swivel is something that the rotary rigs have that basically allows rotation underneath. So everything below the swivel rotates, everything above it does not rotate. And this is held by the hook load, by the hook basically, of the traveling block. Okay, now the rotary hose is attached to the swivel. Remember, the swivel is stationary, doesn't move, doesn't rotate. Everything below it rotates. So you want the mud to enter the swivel because that's stationary. And there is a pipe in the swivel called the wash pipe. This is where the rotary hose connects to the swivel. This wash pipe very often needs replacement. Okay, it can leak. Remember, there is you have a high pressure at that point. Okay, high pressure mud. So goes down the drill pipe to the bottom of the well through the bead jet nozzles, and then goes up through its annulus, carrying the cuttings, any kind of dirt they encounter downhole. It comes out through the annulus, and at this point, you are back to atmospheric pressure. So you went from high pressure at the standpipe to atmospheric pressure out of the hole. And then, because you're at atmospheric pressure, it's not moving. You need help to make it move. So you ramp it down through the return line, which is inclined to use gravity. And then it goes through a series of equipment that clean it up. Now here, the way they arrange them in this picture, it goes from cleaning of big particles, shale shaker, then smaller, desander, smaller than that, desilter, and then smaller than that, degasser. But in real life, you have degasser first. You have something else called possum belly. It's not always arranged from a thicker particles to the smaller ones. But the way they did it here is it was just they make an arrangement from the bigger particles to the smaller particles. Sand is bigger than silt. Silt is bigger than gas. Shale is like big chunks, you know, pebble like. Okay, and after that, here is dirty, you know, here is dirty, here is clean. So it cleans it up and you are ready to go back in. So this is the system in a nutshell. Sometimes you can do reverse circulation. Drilling mud passes through the suction line and the mud pump circulates the mud through the discharge line, the standpipe through the rotary hose, and the swivel back to the Kelly and the drill pipe down the well. One thing I wanted to say is that you understand that the mud pump is is shaking, right? By operating. It moves up and down like it's shaking. The whole thing is trembling. If you had a mud pump here and it was working, you would get a headache. Same thing with shale shakers. They are vibrating screens basically. But there is a lot of vibrations going on, so you need to control them because there are moving parts that you don't want them to be touching each other. If they touch each other, there is friction, a lot of problems. Okay, so you have this thing here that is very distinct. And if you go and see, we have a mud pump in Dracola too. You will notice it. It's called pulsation dampener. Pulsation dampener. So what it does, it dampens the pulsations. It lowers the vibrations. It basically has a diaphragm with one kind of fluid above it, like water, and then basically the mud is below it, and it basically dampens, it slows the vibrations down. This is how it works. But it's very distinct. If you see a mud pump, you are gonna see the pulsation dampener. Like if you go online, let's see, be careful Googling mud pumps. Mud pumps, well, oil rig. Images. There you go. This is the pulsation dampener with red. Right, you see it.
It comes with the mud pump.
Yeah. And you can change the diaphragm if you need to, etc., etc. It's rare that I never saw a diaphragm of a pulsation dampener needing replacement, but it can be. So the mud flows out of the well through the mud return line. Upon its return to the surface from the hole, the shale shaker, then the adjacent desander, desilter, degasser to clean it up and back to the mud tank. Not in that sequence. Now, sometimes you deal with gaseous drilling fluids. It's a little bit of a niche, but you may be using aerated mud. In that case, there are some changes to the system. You no longer have a mud pump, you have a compressor. Remember, you are dealing with gas now, right? So you have the standpipe again, blah, 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 everything is the same. But then when you enter the well, goes in, out. When you exit, you are not in atmospheric pressure. You are in a pressure higher than the atmospheric pressure. So you have what we call rotating head, because you don't want the gas to escape there. It's a it's a hazard that you can have a flammable thing. Somebody might, one of the roughnecks may accidentally brush metal against metal, you make a spark, and then suddenly the whole rig floor catches fire. You want it to die. You want to direct it through the bluey line to a place where it's burned properly, safely, far away from everything. So there are some differences. You have a rotating head below the rig floor, preventing the escape of gas in advance to entering the drill string. Gas returns from the annulus and vents through the bluey line to the reserve pits at a distance away from the rig. It can even burn at the end of the bluey line, which is what the example I gave earlier. You don't have to destroy it, but you could destroy it if you don't want it to be replaced. And obviously, you cannot have a mud tank because it's going to be open to the atmosphere. You need to have something that is closed so that you don't lose the gas. And generally, like I said earlier, if you have gas, you have things with high pressure, and they are very dangerous, things with high pressure. They can explode anytime. You may have trap pressure that you don't know about, and things can happen, etc., etc. Be very careful. Explosion hazard everywhere. Everywhere in the system, basically. And this is a picture that I took from the rig that we visited last field trip. So there are some things that you can recognize by what you know now. For instance, what is this? The sleeves. Oops. What did I do? Sorry. What is this? The drawers, yeah. What is this? The mouse hole. That's the next joint that is gonna go in. The mouse hole. What is this actually? It's actually the standpipe, and it's not taped to the legs of the rig. It's just hanging there, but probably needs to be taped or like attached to the legs. That's the standpipe that I mentioned earlier. What else do we have? This is not a rotating table because this was a top drive rig. We're going to talk about top drive later. This is the cut head, which is used to help make connections and break connections. This here is a bucket with dope in it, pipe dope. It's some kind of grease that they put on the connections to make it connect. And it's very bad actually for the well. It creates a lot of formation damage. So people have experimented since 15 years now that I know on making pipes that connect without dope, that are easy to connect to avoid having formation damage, but it's still, they don't do excellent job. Let's put it this way. A lot of room for, maybe some of you may work into a company that works on that, dopeless pipes. I know Tenaris used to work on that back in my day when I was a student. Yeah. Standpipe, slips, yeah. So the functions of the drilling mud. I mean, we talk about drilling mud, and we know that this is a very important component of the drilling operation, the drilling mud, right? Somebody said once that there are two important things when you drill: data and drilling mud. Okay, so the drilling mud, it points to Bokun's question, like you are going to see later why, but I said that the casing design has to do a lot with the range at which the mud density needs to be. Okay, but when we drill, we don't just care about the mud density, we care about other stuff. We care about viscosity, we care about content of salts, we care about solids content, we care about a bunch of stuff about the mud. So, but what do we need the mud for necessarily? We want to manipulate these properties so that we get the mud to do what we want for us. What is it that we want the mud to do? We want it to prevent kicks. Okay, for that, when we drill a formation, we apply, we have a column of mud above it, right? Okay, that column of mud weighs a certain weight, right? Depending on its density. Okay, I have if I'm drilling a zone 10,000 feet beneath my feet, and that zone is like 5,000 psi pressure, the pore pressure on that formation. I need the weight, I need the mud that I'm using to apply this weight to that formation, so it suppresses it. Otherwise, I'm gonna get a kick. Okay, so for that, I need to have the density at a certain level. Okay, now that level is the pore pressure value, more or less. But I cannot have it very high. If it's too high, I may have another problem, which is fracturing. So I cannot have it too low, I cannot have it too high. That's the mud window, basically, I need to be in to prevent kicks. I also wanted to transport the cuttings to the surface. That means it needs to be a certain density, a certain viscosity to carry the cuttings to the surface. But it cannot be a very heavy viscosity, then it would be impossible for me to pump it. I need to have tremendous pressures that are beyond what my equipment can do. It cannot be low viscosity because then it won't be transporting any cuttings to the surface. I need to maintain wellbore stability. Basically, I need to make sure that my hole doesn't collapse on me, because if my hole collapses on me, I'm in trouble. And these are stuff that we did in geomechanics, or we will do in geomechanics for the undergrads. It's similar to pore pressure. It's like you have a value. If you go below that, you are in trouble. It's like You also want to prevent formation damage, which is something that we learn about in well completions. Basically, you don't want to damage the region, the reservoir around the well, because then the production people would be mad at you, or the reservoir people. A lot of ways you can damage the formation. Sometimes you drill, you damage, you complete, you damage, you produce, you damage. Sometimes you stimulate the well, you damage it. You know, it's like very easy to damage.
But sir, is it evitable that when you drill, you prevent damage? Is it 100%?
Well, I mean, you do damage regardless, but you can mitigate it as much as you can. Sometimes there is not much you can do about it. I mean, pipe daub is like, it's causing damage too. Yeah, I mean, it's things that are inevitable most of the time. Oh, you want to cool and lubricate the drill string. You don't want the temperatures to go too high. You don't want the temperatures to be too low. You may have like salts that can form when the temperature is out of control. Also, you want to provide information about the wellbore. Many times, you have signals that are transported through the fluid by what we call piezoelectric transducers, transducers that create pulsation waves in the mud, and they transport signals. So you have, like, for instance, you are drilling, you have a logging while drilling tool. How does information from that tool come to the surface? A lot of times is with mud signals traveling through the mud. And you want it to act as a protection barrier to personnel, equipment, and the environment. Now, from those 7 bullet points, the first 2 are the primary functions. So I want you to know these, but especially the first 2. The rest are secondary or tertiary functions. So, any questions about this? Okay. So this is what we want to achieve. Okay, this is our objectives using the drilling mud. Now, we want to manipulate the properties of the drilling mud to achieve those objectives. So how are we going to do that? What properties are we looking at? The first one is one that you're already familiar with, the density, the mud weight, basically. The second one is the viscosity. The third one is the filtration rate, solids content, and many more. You have somebody called a mud engineer who is responsible for this stuff. This is a very experienced rig crew member, and he has people working under him. So what he does is that he says, okay, our mud weight needs to be this value. Our viscosity needs to be this value. So this is the recipe that we need to mix. And he tells people, mix 32 sacks of barite with 880 gallons of water, blah, blah, blah. He tells them, like in layman's terms, what they need to do. And they do it. They go out and do it for him. He or she, it's going to be a he, formulates the right mud formula for its job, and he monitors and maintains the properties to the desired level. He is responsible for the mud to be at a certain level. So every time there is a stuck pipe problem, when you get stuck, the first fingers will be pointed to the mud engineer. And the mud engineer will say, but we are getting good returns. Why are you blaming me? So these are the stuff that about the circulating system so far. We're going to get deeper later on. Are they waiting? They can wait 5 minutes.
Yeah, sorry.
Yeah.
The time was.
Yeah, 5 more minutes. The last system is the rotating system. Oh my God, we have questions in the chat, sorry. have to run things. Okay, somebody left. The rotating system is the last one. Well, the second to last one we are gonna see. That's all the equipment that are used to turn the drill bit. Okay, you know you are drilling 10,000 feet underground. You are rotating a bit 10,000 feet below your feet. So how do you do that? How do you transmit this rotation? The answer is through the drill string, those joints that we talked about, or those stands. If you rotate the top, it rotates the bottom. The bit is attached to the bottom, but you need to provide the torque with two ways. One is the traditional way, which is the rotating table, also known as the Kelly rig. That's the traditional type of rigs. You won't find one of those in Williston. You will find some of those in Permian, but those are old style. Okay, that's the one that we saw earlier with the swivel. And I said the swivel doesn't move. Everything below it is moving. So the question is, where is this motion originating from? And the answer is from the rig floor. They have what we call the rotating table on the rig floor, which is rotating. So you pass the drill string through the rotating table, it rotates, it makes the whole drill string to rotate. Everything below the swivel is rotating, even the bit down hole. The other type is top drive, which is basically a swivel that is specially designed to provide the rotation. So you don't have a rotary table at the rig floor. You have the swivel rotating. It's called the top drive. And it doesn't look like a swivel. It's like a big machine, very heavy, that moves up and down. This is the more modern kind. All the rigs in Williston are like this. Rotation is transmitted to the downhole, to the bit downhole through the drill string or drill stem, consisting of the drill pipe, what we call bottom hole assembly or BHA. That's a collection of heavier drill pipe called drill collars, and then some other specialized equipment like logging while drilling tools, some like rotary steerable system to create direction to your well, and some expensive equipment. It's called the bottom hole assembly, and then the bit. So if somebody asks you, what does the drill string or drill stem consist of? You'll say three things: drill pipe, bottom hole assembly, and the bit. And we will see those, I guess, next time. I don't want to get into too much detail today, but we are going to see the rotary table main components next time, and then we are going to see the top drive, and then we are going to proceed with some other stuff, getting more and more deeper. Thank you very much. I have office hours today at 1 to 4, and I will see you all on Thursday.
Thank you.
Yeah, be safe out there. Be careful, because when the temperature is close to freezing, a liquid layer is on the road, on the ice, on top of the ice, and that's what makes it, yeah. If it's above freezing, it's good because it's dry. But then when it gets, if it's too below or too high, it's good. When you have that in between, that's the dangerous part. Takes away from the friction between the tire and the road. And thank you guys. I will see you on Thursday. Yeah.